Hi everyone. The topic of today's lesson is to find areas of polygons, and this is in chapter 11.3 in our textbook. Our objectives are to find areas of kites and rhombi and to find the areas of regular polygons. So remember that a rhombus is a four-sided figure, so it's a quadrilateral in which all four sides are congruent. If you recall, earlier in the year we talked about how squares are a special type of rhombus. A square is a rhombus that has four 90-degree angles. And a kite is a four-sided figure that has two pairs of congruent sides. So you've got two pairs of congruent sides just like a rectangle does, but opposite sides are not congruent. So this side is not congruent to the opposite side, and neither is this one. All right, and there's an example of a kite. So the area of a rhombus or a kite is given by this formula here, and they both use the same one. The area is 1/2 diagonal 1 times diagonal 2. Now there's a really simple explanation behind that, and I'm going to try to draw a full rectangle around this rhombus here. All right, so as you can see here, instead of using D1, we used base. Called this the base, and let's say instead of calling this D2, we called this the height. Notice that the area of that shape would be base times height. Now, the thing is, half of the shape is missing. You only have this half, and you only have this half filled in, and you only have this half filled in, and you only have that. So only half of that rectangle is filled in. So we could get the area of that shape by using 1/2 base times height. Now instead of using the base times height notation, we use diagonal 1 and diagonal 2. So let's go ahead and try that out, and you'll see it's a very easy formula to use. So on example A here, we are going to simply find diagonal 1 is basically just the sum of these two portions here of this segment, this little bisected segment. So that's a total of 30. And then this segment here, which is also bisected, is 16. So when we plug that in, we get 1/2 30 times 16, and that area is 240 square feet. Now, my writing tools may be blocking that, so let me write that again. So 240 square feet. So as before, you can multiply 30 times 16 and divide that by 2 if you'd like. All right, so for B, notice that you are already given the entire diagonals. So you've got 7 and 10. So 7 has not been bisected. That's the full diagonal. And so is 10. So here we're just going to multiply 1/2 10 times 7. So 10 times 7 is 70. And if you take half of that, that will be 35 square centimeters. All right, and again, this was a kite, and this was a rhombus, and regardless of the fact that these are technically two different shapes, we use the same formula for both, 1/2 D1 times D2. All right, so please pause the video for a moment and try these two problems out, and once you're done, check back for the solution. All right, so on the first problem, notice that you have a rhombus with the full diagonals given. And on the second problem, you are given a kite. And in that case, we're going to have to add both parts of those segments to find the full diagonal. So here are the solutions that you should have calculated. So again, down here, this is 24 square meters. And we just multiply D1 times D2. And it doesn't matter what you call D1 and what you call D2, you'll get the same answer regardless of how you set it up. So for b, we do have to add 6 and 6, and that gives us a total of 12. And along this diagonal, 2 plus 10 is also 12. So 1/2 12 times 12 is 72. Since we don't have any units given, we just write units squared. All right, so on this problem, notice that we are given a rhombus, and remember the diagonals of a rhombus bisect each other, so that is 14. So we definitely know information about one set of diagonals, and one set is 28, but we do not know the information about this diagonal. However, we are given information about the outer side length. So here we're going to have to use, again, the good old Pythagorean theorem. So we're going to set it up just like so. 14 squared plus x squared equal to 6 squared. So again, we are using our Pythagorean theorem, and the outer side is our c. So that would be our 16. All right, so now we simplify. 196 plus x squared is equal to 256. When we subtract 196 from each side, we will get a total of 60. And that gives us x squared equals 60, and that's approximately 7.746. 7.746. So now we want to try not to round too much. So in other words, don't round that to 7.7. If you round it to 7.75, that's okay as well. I tried to add as many digits as possible, and when I doubled this side, multiplied that by 2, I get the length of our other diagonal, 15.492 approximately. So this entire diagonal is 15.492. The initial diagonal that we knew, that full one, was 28. So 1/2 28 times 15.492, and then divided by 2, or just taken in half, will give us 216.89 square units to the nearest hundredth. So once you're done, you can go ahead and round it. But try not to round to the very end. And if you do, your answer may be close to this. You may end up with, even 215, possibly if you say round this to 7.7. But again, try not to round to the very end if that happens. And in this case, 216.89 square units is our solution. All right, so pause the video again and try this out and check back when you're ready for the solution. All right, so here we are given the length of one diagonal. Notice straight across this way is a distance of 12. So that would tell us that this diagonal is also 12. So we know our D1 is 12. Now, we don't know this diagonal, but if we bisect the 12, so let me go ahead and draw out a separate triangle here. If we bisect the 12 and make that 6, we want to find this distance x, and we know the hypotenuse of that right triangle is 10. So if you remember your Pythagorean triples, we are looking at a 6, 8, 10 triple, which means that this entire diagonal will be 8 and 8, which would give us 16 in total. So when you see the solution, when you see the solution, you will notice we will have a diagonal of 16, and we have a diagonal of 12. So in our solution, we take 1/2. We take 1/2 12 times 16 to get a final area of 96 square centimeters. All right, so now we're going to move on to our regular polygons. Recall that a regular polygon is one in which all sides and angles are congruent. So this formula that I am going to show you only applies to regular polygons. Now, we first need to define this term called pronounced the apothem. And the apothem is basically a segment that is drawn from your center of your regular polygon, and it is perpendicular to the side. Okay, so notice it lands right in the middle, and it actually will bisect this entire side length, and that's called the apothem. All right, so now the area formula for a regular polygon is given by 1/2 side length, 1/2 s, so it's the length of this side, times the apothem, times the number of sides. So this formula is given as 1/2 SAN. 1/2 SAN. And in some textbooks, you may see it written like this. You may see it written as 1/2 perimeter times apothem, 1/2 PA, because when you multiply the number of sides times the side length, those two values are equivalent, these two are equivalent to the perimeter. But our textbook gives the formula as 1/2 SAN. So please write that down and put it in a safe place so you can refer to it. All right, so in this example here, we're gonna find the area of this regular pentagon. So notice that the side length is 9, that's our S. The apothem is 6.2, and we are given 5 total sides. So the area of that is just going to be the product of these three numbers, just taken in half. That's how I usually do this to make it easier. I multiply these three numbers first, and then I will just divide those values by 2 or multiply them by 0.5. Whatever the case, you should get 139.5 square inches. Okay, so please pause the video for a moment, and I want you to try this problem out and check back when you are ready to see the solution. All right, so here we are going to find the area of this regular hexagon. So there are 6 sides in total. So we are going to use the side length of 14, an apothem of 12, and a value of n equals 6. And as I explained earlier, the easiest way to figure this out is to multiply those 3 values and then just divide that by 2. And you should end up with an answer of 504 square feet. All right, now before I let you go, just a little bit about where this formula comes from. Involves the fact that every regular polygon, so let me go back one slide here. Every irregular polygon can actually be separated into congruent isosceles triangles. So if you think of this problem as, this one in particular, as a lot of different bases times heights. So in this case, it's 1/2 base times height, and there's 5 copies of that triangle, right? So there's n equals 5. So it's 1/2 base times height times the number of triangles. And it's a number of triangles that are really the reason why you're using the number of sides. So to give you a specific example, let's go back to this one here. Let's say we treated this problem as 6 different triangles. So I can say I want 1/2, and I know all of these triangles have a base of 14. 1/2 14 times 12. And then I want 6 copies of that triangle. 1, 2, 3, 4, 5, 6. And 1/2 14 times 12 times 6, notice, is the exact same thing as our formula 1/2 SAN, which gives you an area of 504 square feet. So feel free to just keep that in mind and use it if you ever get stuck. All right, have a great day, everyone. I'll see you.